My name is Wolfgang Goerlich, as already covered. I am with Duo. I'm an advisory CISO, and what that means is I tend to spend a lot of time talking with other CISOs, a lot of security teams, and saying, what do you do? How does it work? How can I help you? Have you thought about this? Do you have any rum? It's a great time. But recently, I've been thinking about cybersecurity and thinking about some of the problems we have and trying to figure out different ways to do it. So I've been wondering, is cybersecurity like a form of artistic expression, right? Is it a form of creating and communicating to people? And if so, and I'm postulating in this talk that it is, and if not, argue with me, we'll have all of the day and into the party. But if so, what can we learn from designers? What can we learn from artists? What can we learn about how cybersecurity can get implemented such that people follow what we ask them to do? Because we know they don't, right? They don't. We build all this great security and people ignore it. We build all this great ideas and people are like, yeah, okay, that's fine. Because ultimately, if security happens where mankind meets the machine, this is where it breaks down. Constantly, we build this beautiful system, we build this beautiful app, we stand up these servers, it's fantastic, and then we invite the users in. And that's where everything goes to hell, right? It's like in the 90s, we had this concept of endless September, because in September, kids would come back to school, they get on the machines, we'd have to teach them how to use Usenet and everything else. And then about mid-year, they'd figure it out, and they would settle in, and life would be good. And then September would happen again. But then, of course, everyone got on the internet, and we've now had this endless September where people are screwing with our machines. Phishing is like the #1 way people talk about this. Yeah, okay, phishing is a problem. We know this phishing is a problem. Business email scams are all over the place. I heard recently that you can make more money off a business email scam than you can robbing a bank, which I think is just terrible. Because think about all the bank robbers, right? It's like, man, it's exciting. You got the gun, you got the people yelling at you. It makes for a good movie. And now what? Now we're just going to have people at home sending phishing emails? It's going to be like the most boring movies ever. It's terrible. But we know this is usually where security awareness stops, though, right? If we can just get people not to click on the links, if we can just get people not to open the emails, we'll be safe. But we recognize, or at least we should, that most of the other problems that we face are also where man meets the machine, specifically developers. This is my favorite picture for software development. It's on row 3 of Google, if you Google software development. And I love this picture because right here, right away, is a SQL injection string in the image that we even use to talk about software development, not to mention the fact that we teach developers to write code with vulnerabilities. There's like no security given to these students whatsoever. And we see these problems very, very consistently. I started an OWASP chapter many, many moons ago. I gave lots of talks on SQL injection. I was up at Confu and I was giving lots of talks there about it. And we were comparing notes between the local OWASP chapter and the Detroit OWASP chapter. And after 10 years, I realized I was not getting anywhere. And I felt really bad. I thought, maybe it's just me, maybe it's just me. But then I saw the Veracode numbers and I recognized that, no, it's really, we're not getting anywhere. 10 years, volume 1 to volume 10, Veracode report this year, 10 years, 1 in 5 applications have SQL injection. Again and again and again, almost a flat line. Consistently, we introduce developers to our machine. We say produce code, and what do? They write bugs. It's like job security for pen testers. So think a developer, buy them a drink. But I don't want to just blame developers, because it's also where people stand up equipment. People stand up equipment on-prem, people stand up equipment in the cloud, and they make all these mistakes and they cause all these problems. We hear about it all the time, and the Verizon data breach report says it's about 21% of all the breaches. 21%, 1 in 5 of the breaches are caused because someone stood up some software and they weren't paying attention. On Monday, I do this video every once in a while in my car when I'm driving and I'm thinking about something. And on Monday, I saw that there was a breach because someone had put up an S3 bucket. On Tuesday, I went, oh, I want to do a video about that because I want to talk about how easy it is to put stuff in the cloud unencrypted and an S3 bucket with no username and no password, because we hear about these things all the time. So Monday, I see it. Tuesday, I can't find it because there's been 5 other breaches that have happened since then where someone's like, oh, I copied up our backup file and I put it in S3. And oh, by the way, it has usernames and passwords and all the customer information in clear text in the cloud. I just want to strangle these people. So we know it's 21% of the breaches. When you look at pen testing, this data comes from Alyssa Miller, who runs a pen testing team at CDW. she and I were complaining about this. We're having a conversation. She goes, I find the findings all the time in pen tests related to misconfiguration. I'm like, awesome. How often? She goes, a lot. I goes, like, raising or lowering? She goes, I don't know. Let me run the numbers. And she ran the numbers for 3 years, quarter after quarter, 40%, almost again, a flat line of people who are putting IT in place in a known vulnerable way that's only getting discovered at a pen test. So we got people clicking on stuff. We got people writing code. We got people putting on systems causing all sorts of problems. And then we got everyone using their phones, right? The good old days, they're on my systems. And I like that. I controlled that. I owned that. I locked it down. I gave them a BlackBerry. And I used to like a BlackBerry, by the way. Big Brocker, you know, it's fun. It's a good time. Thank you. A couple of the older beards are like, yeah, Big Breaker. I used to joke. My wife would be like, you know what? You're the kind of guy who'd play in a BlackBerry at a funeral. I'm like, that is not true. When they lowered him to the ground, there's at least like 10 minutes where you could just check your scores. But now everyone, of course, moves to iPhones. Everyone, of course, moves to their own devices. And then they have stupid stuff like screen time that tells me how much time I spend on my phone, which makes me feel terrible. I spend 10 hours a day on my phone. Well, you know what? Again, there's time when they're lowering the coffin. But everyone is on their phones. Everyone's on their devices. The average person right now has 2.3 devices, and 1 in 5 employees has 6 or more devices that they use to access corporate data, access everything else. Very few of them being in the hands of the defender. And of course, now we're all in the cloud, which is even better. What do you do on your phone? You access cloud services. What do you do if you want to get some work done? You spin up a cloud service. What do you do if you need to process some data or do whatever you need to do? Do you call IT? No, because they're too busy standing up misconfigurations for the pen testers. You do a cloud service. Average enterprise right now is using 1,427 cloud services. That's as of January this year. They did a similar survey. They asked the CIOs and the CISOs, how many you're protecting? And they're like, well, I think around 40. A little bit of difference between those numbers, right? So everyone's running services we don't look at, on devices we don't know about, and doing who knows what, who knows where. So the users are turning our worlds upside down. The developers are turning the worlds upside down. Ops are turning the worlds upside down. And then we got new exciting things like DevOps. I like DevOps. For those of you not in the room, I will define DevOps. I define DevOps this way, keeping in mind that software developers are consistently creating issues. IT ops are creating issues consistently. DevOps, I would argue, is failing faster and failing at scale. Because now we can automate those mistakes, right? Put them in a pipeline, make it repeatable, and then the pen testers are going to have a field day. Again, if you're red team, you're welcome. And that's DevOps to the cloud, of course. But of course, we're also now talking about IoT and the Internet of Things, which I would define as failing on new things and failing in new places. I love the idea that a developer right out of college has written a SQL injection flaw that runs on my heart meter when I'm in the hospital, which is on a flat network that I can get to from guest Wi-Fi because I'm bored. This is glorious. But don't worry, the security teams will protect us. The security teams will rein all this stuff in, hopefully by using some of the things that we're going to talk about today. One of the main things, though, that I run into with security teams is everything's out of scope. Everything's always out of scope. I was working with a large organization, multinational, and we're like 5 weeks into a 6-week audit. Oh, and I was running shotgun with your guy, who was great. He's asking all the questions. He was interrupting. It was fantastic. He's a lot of fun, natural. And we're 5 weeks into a 6-week audit, and I'm asking myself standard questions. Do you have asset inventory? Do you have multi-factor? Do you have patching? And the guy's at the end of the desk, and I'm over here, and the CISO's over here. And he turns to CISO and goes, but does this count for our cloud services? And she threw him out of the room. He had to walk like the walk of shame back to the cubicle. She's like, you go now. We are not talking about cloud. Cloud is not in scope. She turns to me and goes, you better remove that. You did not hear about cloud. We are not doing cloud. So naturally, over lunch, I asked about cloud and found out that 2/3 of their development was all in the cloud right now. That was out of scope for our controls. So it's not like the security team is actually jumping in either, right? Which creates a whole bunch of problems. So at our security happens where mankind meets the machine, which means from a design perspective, from an artistic perspective, we got to think about security not being what we control anymore. It's not the devices we control. It's not the apps we control. It's not the people we control, which arguably we never could control them anyways, but I like the nostalgia of saying they would do what I said. I ran IT from a hospital. They never did what I said, but at least it was on my machines. So it's no longer what we control, it's what they do, right? How do we get people to follow the things we put in place? How do we get people to follow along and do the right things and not push back? And that's where I think design comes into play. Industrial design is something I've been looking at. User experience design is something I've been looking at. Just the overall concept of giving people a better way and reason to follow along. That's what I want to talk about next. But first, some first principles. My kids are grown up, which is a shame. I used to have a lot of fun with my daughter. I used to love watching videos with her. I used to love getting dressed up for Halloween. And now they're all gone. And now I have to like co-opt other little kids. My wife took a photo of me handing out candy on Halloween the other day. I'm like, I'm so excited. You guys look great. There was no Moanas because we are, of course, I'm from Detroit. And as we all know, it's cold and wet. And so everyone's got like their costume on with all these big bundles and gloves and everything. But whenever I was watching these things with my daughter, I was always thinking about the cybersecurity. I was always thinking about what does it mean for security. So I'm watching Moana. And the thing that fascinated me about it was the wayfinding. If you remember the story, she was on an island. She found a way to go from here to there. She found a way to navigate by the stars, to navigate by the water. And you may at this point be wondering, Wolf, what the hell does this have to do with cybersecurity? It has to do with this, wayfinding as a way of defining where people are going and what they're doing, as a way of defining a journey. And this journey is usually where man meets the machine again. The things like knowing where you're at, where you're going, tracking your route. We create incredibly complex systems, but thankfully users are incredibly smart. People are very good at wayfinding. If you go back to the Polynesians, which Moana was based on, they could take someone blindfolded, take them out way, way past where you could see in the islands, in the seagulls, anything, take the blindfold off, and they look at the waves, look at the pattern, go, all right, I know where to get, and they get it back. You know, you take an Eskimo out in the middle of the snowfield where you can tell anything, and they go, oh yeah, okay, I sort of see that track over there. All right, we need to go this way, and they get back. We take a user out and say, here's 1,000 different cloud applications. And they're like, all right, I know how to pump the data from here to there and do what I need to do. They get back. And so this concept of wayfinding is very interesting to me. And I think if we think about security as a journey of two different people, right? Two different types. The journey of the users, obviously, the people who we're defining these systems for. This is an HR process flow. Don't worry about it if you can't see it in the back. But you hire someone, you know, you onboard them. You give them their apps, you make sure that everything's approved, you remove any excessive privileges, they get to work. It's a journey, it's a process. You can do process analysis and see what systems they're using on that. Likewise, as a criminal, we can do attack paths, right? We can do threat modeling, we can do kill chain, I don't care what you call it, but the attacker's gonna do, they're gonna infect, they're gonna do some multi-stage movement, they're gonna collect what information they're gonna get out, they're gonna complete their journey. So I like the idea of thinking about this in terms of wayfinding. How can we know where the user is oriented, know what decisions they're making, how they're monitoring those decisions, and how they're reaching their destination, and then inject controls along each one of those steps. Likewise, from a criminal perspective, how do we know where they're at, you know, how they know how they're doing reconnaissance, living off the land, all those things. How can we lay out those steps and then inject controls along this place so we can trip them up, slow them down? That's what we're going to discuss next. I'm also going to discuss choice architecture. Choice architecture is this concept of you can design behaviors for users by giving them good choices. So if we know the IT people are again and again and again, 40% of the time creating bad stuff. If we know again and again and again, people are putting stuff in S3 buckets, and it's open and has no IP address restrictions and no usernames, how can we give them good defaults? When I think about those S3 buckets, you know, and I get so angry at these companies, but then I stop back and think about it. What is Amazon doing? Why hasn't AWS created a better, safer way for us to put stuff up there? Why is it so easy for people to make this mistake again and again? I get 4 times just this last week the breach occurred. And likewise, there's a million different ways in our environments where we're standing up stuff where people are making the same mistake again and again. How can we give them better choices? How can we give them better ways of doing things? So the next part of this talk is that. I'm going to slice it down to usability, talk about manageability, talk about defensibility, and then we'll wrap it up and we'll call it a day. From a usability perspective, I was doing an assessment, and they were giving me a bunch of data to look at. We were also doing some testing, some pen testing, some auditing, the whole 9 yards. And they're like, look, this data is sensitive, it's secret, we have multi-factor requirements. I'm like, good, I like multi-factor, fantastic. They're like, here's a token. Like, oh, okay, are you joking with me right now? Like, no, yeah, here's the RSA token you need to handle, and you need this code. I'm like, all right, that's groovy. I like retro tech. I'm good. Yeah, retro tech, I'm in. But then they're like, all right, and connect to this interface. And that was the most weird VPN interface I've ever seen. It was like 10 years out of date. And they're like, put your username and password in. I'm like, all right, good. And then it's going to tell you your username and password is wrong. I'm like, what? Yeah, so put your username in again, the first 4 characters of your password, and then the PIN from the RSA token. And anyone who does password hashing, there's a little bell that rings off when someone says they know the first 4 characters of your password, right? Because it means they're not hashing it. They're not hashing it. It's in reversible encryption, hopefully, clear text, worst case, somewhere. But all right, fine, first 4 characters. And then they're like, oh, and by the way, it might tell you one more time your password is wrong. I'm like, well, why is that? I'm like, oh, we don't know. Just, if it does that, exit out of everything and do it again. I'm like, fine. But at least we have MFA. At least we have a dedicated username. At least they're protecting this information. Like, absolutely we are. They're like, and once you're in, run this net use command to mount the share so that you can see our files. And I'm like, but that username is our company name. They're like, yeah. So we created a company account internally in AD so you all can share. Like, wait a minute, you just went through all this. Now we're going to, okay, fine. But we're going to map this net user over Wi-Fi from a hotel, which I'm usually at, from an airport, which I'm usually at, and we're going to run this way. Great idea. Because half the time the files won't open or they won't look right. And then I create findings and they come back and go, yeah, but you're not using the wrong version. And I'm like, what do you mean I'm not using the right version? Well, refresh. And I refresh and there'd be new files in there. And I'm like, no version history, no nothing. It was a nightmare of a project. And multiple times to have, like, facepalm moments. Because why are we doing this? And this was the inkling, the germination of this talk, because I'm like, man, as a user, I hate these people right now. I don't care if they pass. They're terrible people. So step 1 from a security perspective is we need to think about designing experiences. We need to think about designing workflow, right? And we need to realize and be cognizant of the fact that users are very creative. The street finds its own use for things, as William Gibson would say. Whatever technology we give, they're going to do whatever the hell they want with. And sometimes that's great, and sometimes that's not so great. There's a university that recently rolled out Duo, and I found out this story from a local Slack channel. So don't know the university name, I'm not going to give that. But what I thought was interesting was this teacher had a problem. The teacher wanted to share this resource with the students. However, the resource was only licensed for one person. So he's like, all right, I got to share these resources. How am I going to do this? Well, I'm licensed for it. Okay, great. And I've got MFA. Okay, great. So everyone in this room, security conscious, would be, this is awesome. Only one person can use it. It's secure. The instructor's like, no problem. I'll write down my username and password on the board, and that way everyone can log in. And when I see them log in, I'll click approve and MFA to let them in. What? Why are you doing that with a security control? He goes, well, in Duo, it tells you what city you're in, so I know if they're in my city, they must be okay. I'm like, are you reusing that username and password? He's like, right? This is terrible. Users will find creative, scary things for technology. So back to my story. I'm having all these audit problems. And next thing I know, one of my guys is like, this is fantastic. Good news. We've got a website where we can work off these files. I'm like, that's awesome. All my problems went away. When I'm traveling, when I'm working, everything is great. All these files are up in this website. Like, whew, dodged a bullet there. For about a month until I got a customer call. They're like, website? I'm like, yeah, this is fantastic. Why don't we start with this? Your files on a website? Yes, I'm saying you should start with this in the first case. We didn't authorize any files to go on a website. Oh. Well, turns out my guys had copied all the files up to a Dropbox so they could share it with us so that it would make my life easier. Awesome, thank you. But the customer was less than pleased because now we had all this sensitive information up there. It avoided NDA, it bypassed all the security controls, right? But I'd argue it wouldn't have happened if they'd given us a better solution in the first place. So the first thing is, when we're thinking about wayfinding, when thinking about designing experiences, we want to look for ways to minimize the steps, minimize the process the user needs to take. About a year later, I was doing a different audit. They're like, we need you to use our files. I'm like, oh, damn it. But it's off box. I'm like, all right, I like you guys. And by the way, you can use your existing MFA. I'm like, fantastic. And oh, we're going to be changing the evidence as we go, so watch the version history. It's in box. I'm like, I love you guys. You passed. Stamp, right? I mean, that's easy. I can do those steps. It makes sense. I can read my files from anywhere. Why didn't the first company do that, right? Why didn't they think about it? Well, they didn't think about it because they had controls they put in place and they didn't think about the user experience. So first thing is minimize the number of steps. Next thing is we want to make those steps familiar. If people don't recognize the steps, they're not going to do it, right? If work looks like work, work gets done. But if it doesn't, people push back because they're busy or whatever. Great example of this is actually these cocktail cards. These cocktail cards were created by Jamie and Hafsa. There's a Twitter handle if you want them. They're mocktails. So they're a bunch of mocktails, description of what they are, second factor, red team Ricky, detect and respond, salted passive, right? Mocktails. And they created these and they're like, we want to go to a bar and say, okay, I want this instead of rum. Now there's a problem though. They would ask the bartender would be like, I'm too busy for this. Too busy right now. And so what they ended up doing was changing the cards, and this really highlights the issue. I don't know if you guys can see in the back, but they added all the ones based on blah, blah, blah. Second factor based on mojito. Just this one change right here. Just this one change, so that when they ask the bartender, they can go, well, you can make a mojito, right? Well, of course I can make a mojito. Yeah, this is based on that. That one change dramatically increased the likelihood of bartenders actually following along. And I'd say the exact same concept applies to security folks, right? If we can make the steps something familiar, if our login process is familiar, if our security process is familiar, the way exchange files is familiar, we can make the steps familiar, users will get in. If work looks like work, work will get done. And then reduce some friction. So I'm going to tell another story about RSA tokens. Why I thought it was kind of retro. I was a security officer for a financial services firm for many years. And we traded on Wall Street. We traded on a whole bunch of different exchanges. And every exchange had a RSA key. Every app had an RSA key. And much like the education space, it was only licensed for one user, right? It was only licensed for one user. It was very expensive. And you got this little MFA token. So all of us had this basically like key ring of MFA tokens. So pausing there, I was setting up a vulnerability management program. I'm scanning my network. I'm scanning my network for new devices, right? Asset inventory, number one control. We're scanning. We're going to know what's out there. I find this thing. It's a weird thing. I'm like, what is this thing? I'm trying to interrogate it. The scanner doesn't recognize it. So I'm on IRC. I'm there. Go try this, try that, try the other thing. We're troubleshooting. We're trying to break into this thing. We realize it's a like Best Buy, like off-the-shelf webcam. So you must appreciate that's probably really secure, right? Probably really hardened. There's no possible way the default password worked. I was in. So I'm looking down at a table from this camera that I just remoted in. And this table is white. And it's really nice. And it's got these neatly printed labels that an admin had set up for all the RSA tokens with all the usernames and all the services. MFA, something you have and something you webcam into with a default password. And the reason they did that, of course, is because it introduced friction to their steps. So we want to reduce those steps. We also want to decrease the friction between the steps that the person is taking to complete their work process. There's this idea in design called creative constraints. The more constraints you put on someone, the more creative you are, which is why a lot of times I'll make my slides like 5 minutes before. No, not today, not for Hackfest. I actually had these in advance, thank you. But a lot of times if there's a lot of constraints, you are a lot more creative. The problem with that is applied to users. If there's constrained users, they are very creative. And creative users are very dangerous users. Creative users, because of our constraints, have now been incentivized to hack our controls, to find ways around it, to copy files out, to find different ways to break around whatever we put in place. And it's not just users, again, it's also software development. So earlier, I think it was this year still, Chrome got rid of their network process API. Before you could, in a Chrome browser, interrogate a device and communicate with software on it. You could do things like a device health check. You could, ask all sorts of information. Chrome gets rid of it. And so people are like, damn it, what are we going to do? So a lot of people are trying to be creative and come up with new ideas. And what that meant was folks wrote really tiny, small web services that their app could talk to. Trend Micro did this for an AV. Kind of makes sense. I guess your AV wants to be able to talk through your browser. That kind of makes sense. Logitech did this for the mouse. Don't understand that one, but okay, now your mouse has a web service on it. Awesome, awesome. Why not run some code, I guess? Gets weirder because MicroTorrent did it too. Kind of makes, not really. But Zoom was the one that captured all the attention. Zoom did this exact same process. And then in Zooms, there was this vulnerability that would allow you to take over the webcam and the mic on your Mac, which you guys probably heard everyone up in arms about. Oh my God, with this web service on Zoom. So everyone uninstalls it. Well, then the other problem was Zoom didn't create an uninstaller, so the web service was still there, vulnerable, even though you thought Zoom was off your box. Quite a lot of problems, and everyone panics. But it wasn't just Zoom. MicroTorrent had remote code execution. Logitech had a injection flaw that led to execution. Trend Micro, your AV is running a system. If you can get to Trend Micro as a system, you can do a lot of damage. Google introduced a constraint. The devs get creative, and suddenly we've got vulnerabilities and microservices all over the place. You can go ahead and look all these up. Pretty interesting stories of each one, but I really think drives home the point, right? We need to think about the technology side, but also the psychology side. We need to think about how we're introducing constraints on the users and how those constraints are driving them to different behavior. We need to think about ways to be kind while we're asking more from them so that they still buy in, still play by our rules, and don't go off and run things on their own devices in the cloud. I'm going to skip that slide. So, by designing for usability, reducing friction, and reducing effort on the users. Let's talk about the manageability side of it for just a minute. I promise this is not a whole bunch of Disney characters, but is everyone like on the mode? Right? Only thing I don't like about it was no capes. Halloween, I was rocking a cape. I wanted my cape. I think, by the way, if anyone wants a trend in cybersecurity, that'd be great to start in Canada. Capes. Red team, blue team, it'd be fantastic. Thank you. She was based on someone called Iris Apfel. I was watching an Iris Apfel documentary because my wife's like, you're in design, you're in art for this whole theory. You should watch these documentaries with me. I'm like, I have no interest in fashion. This has nothing to do with cybersecurity. She's like, you should watch this, you'll like it. 39 minutes in, I said, pause it right there. She pauses it. I go, that's brilliant. I'm blogging on that. She goes, see, I told you. You're right. You're right. Wives are always right. That's the other thing I've learned. But what's interesting is she's collecting all these material, right? She's like, oh, this comes from Versace, and this comes from a resale, and I got this one for free down in Harlem, and I got this one 20 years ago, and I don't even remember where. It's like 60 years of materials and ranging expense and whatnot from all different things. And she puts it together into design that all makes sense and is consistent. I'm like, my God, if that's not the quintessential sock, except for the whole design being consistent, I don't know what is. Because oftentimes in organizations, I'm talking to orgs that have been around for 100 years, and they're still dealing with mainframes and printing presses and antiquated technology. So how can we make these things better and easier to manage? When I was at the financial services firm, we were running CIS, critical security controls, and I was doing a series of tabletops. And one of the controls was block people when they have disabled accounts and log in, right? You can't log in with a disabled account, but block an alert on that account from an IP address. So we stood up that rule. We piped into QRadar, not a QRadar story, but that's what I was using. And it went great. So Thursday, we had this lunch and learn. We had the control in place by Thursday evening. Friday, I had off. Monday, I had off. I'm on vacation. I come back on Tuesday, and our alerts are through the roof, through the roof. Someone spent the whole weekend trying to break in. I'm like, what the hell is going on? We found out there's a flaw in the VPN. When you delete their account instead of disabling, it's still connected for whatever reason. And we had fired someone, deleted their account. They went home on Friday, still had a company computer, didn't have to return till Monday. Spent the entire weekend trying to break into our systems with this disabled account. Hundreds of alerts. And I go to my SOC guy. I'm like, why didn't you respond to this? You saw I was gone. I was trusting you. Why didn't you respond to this? He goes, Wolf, can I be honest? I'm like, yes, be honest. He's like, you're always doing weird shit, man. Okay, fine. And I used to tell the story as like, SOC people don't get it. SOC people don't get it. Until I was telling the story, and a guy comes up to me after the fact. He goes, yeah, but how many systems are we having him monitor? He goes, you're always talking about how security should be like bells on strings, right? Where things get alerted whenever attackers are moving through your network. How many alerts did you have him looking at? I'm like, don't you make this about me. This was him not doing his job. But the reality is, oftentimes our SOC folks, we ask them to do so many alerts, so many systems they can't keep up. And a fatigued security team is incredibly ineffective, right? If you think about creative constraints for the user, on the manageability side, we've got to be thinking about cognitive load. What are we asking for these folks? How much are we asking for them? Because more is definitely not better. I talk a lot about the single pane of glass. Arguably too much about the single pane of glass. That's interest from Google over time. I'm absolutely sick of the single pane of glass, but it keeps coming up in marketing material. And it sounds great, okay? We've got single pane of glass. And then you sit down with folks, and you're like, hey, how do you triage this fish? Well, the fish comes in, and maybe it came in from a user report, so we're in that console, or maybe it came in as they're going out through DNS, so we're in this console. So anyways, we then triage it with our phishing tool, and then we go back to our firewall to see if it went out, and then we go onto the web to check the MD5 and the hashes of the system, and then we update our ticketing system, and so you sit down with someone in the SOC, and they walk you through the process. They walk you through the workflow, right? They lead you down that wayfinding process. And you're like, my God, that was 30 minutes to triage one fish. Like, yeah, absolutely. Like, how many fish do you get in a day? They're like around 160. Like, you look at all of them? Yes. No, you don't, right? Single pane of glass, my ass. So a few rules there. A, we need alignment, right? Communicating the position of information and actions, alignment across the process for SOC tools. And B, we need unity. Unity of purpose, unity of motion. I think we're going to get a lot of that from SOAR. I think we're going to get a lot of that from better orchestration, better automation. But today, the task we ask of the people managing the tools we build is incredibly difficult. There's a concept of double diamond model in design, where you try and figure out if you're solving the right problem, and then you try and get to the right solution for the problem. I think this absolutely applies to incident response, because you have a divergence and convergence of finding the right problem. Is that not trying to figure out if you're breached? And does that not take most organizations around 180 days as they go back and forth through this, trying to figure out what's going on and whether or not they need to act on it, or if it's just wolf being wolf? And then once you know you're breached, you got to go through all these other tools to clean up, which on average takes around 90 days right now. 180 days to figure out the problem, 90 days to implement the solution, while the criminals are running circles around us. Because of that good old double single pane of glass. So I've got another friend who runs a SOC. It's worldwide. It's a magnificent building. He's also running IBM Curator. Again, not a Curator commercial, just coincidental and instrumental in saying it's the same technology we're both running. He's got, all the monitors and 4 different teams staring up at all the different things, but he doesn't have a pew-pew map. And I'm like, why is your pew-pew map, man? You got that monitor right in the middle. It's blank. Why don't you have like nation state actor, bombs and explosions? He's, oh, because that'd be stupid. I go, but it would be exciting. He goes, but it would be stupid. Point taken. What he actually runs in the middle monitor is a 4x4 grid. It's like a check engine light, 4x4 grid. He's got defined use cases. And whenever any one of these lights lights up in the middle screen, all the work stops and the team goes to work troubleshooting just that. Forensics teams, IR teams, level 1 teams, comms teams, everything just based around this monitor, right? These very specific use cases. And I asked him, I said, well, 4x4, that's probably 16. Okay, so what happens if you have another use case? He goes, I get rid of one. I go, how do you know which one to get rid of? He goes, whatever one we're not using. Well, how do you know which one that is? He goes, well, metrics and results. I go, this is ridiculous. You should ask your users to do like 200 things. That's what SOCs do. I want a pew-pew map and a SOC team with 200 use cases. He goes, no, everything collapses down to this. And I love that idea of simplicity, right? So when we're talking about designing for manageability, what we want to do is say every time we have an addition, there's a subtraction. We want to think about the cognitive load of our SOC team as something that we're managing for and managing around and managing to, so that we can make sure these guys are focused and know what to do a few things very, very well, as opposed to trying to bleed them out over a million different consoles. And then unify those steps. With that, let's talk about defensibility. Again, the idea here is attackers are going to follow a path. We can map that path through kill chains, through attack paths, through attack modeling, attack trees, I don't care, whatever process you guys are using. But we know that they're taking a path. We know they're executing a series of steps and tasks to get the work done. And we can use those same human-centered design ideas I presented earlier for users, but flip them on their head to make it an inhumane nightmare for the red team, for attackers and criminals. Starts by coming up with adversarial personas. A lot of the arguments that I think we have in security go something like this. Oh, you're putting in place this panel. I am. That's great. Do I have usernames and passwords? Yes. What are you doing for password spraying attack? And developers like, what is that? And you explain to them, okay, well, someone's going to use a username, password, they're going to run across your whole list, try and get in and figure out what is a good password so they can use it somewhere else. He goes, well, yeah, I could do that. But really, if someone was going to attack me, they're going to be able to crack the hash and they're going to be able to get in through a million other different ways, right? They immediately go from, well, okay, I could stop this automated simple attack, but the criminal, the real bad guy, could do something more exciting, more fancy. And that's where I think we need to stop and start thinking about what is the exact personas we're trying to defend against. And it's all the same things we think about all the time, right? Script kiddies, threat actors, hacktivists, criminals, nation states. But by starting with a persona perspective, we can say, okay, these controls map to this persona, and these are the personas that are attacked against the most often. Therefore, these are the people we need to focus in on to create the right countermeasures, as opposed to just arbitrarily going, okay, it could be any number of different ways they could break in. They could repel from the ceiling. Yes, they could, but they won't. Most of the time, it's malware, right? It's malware and automated attacks that we can easily break. So we start by creating personas, and then we look for ways that we can increase the steps for criminals as they're moving through the process. Now, for a long time, we did not have a good idea of how many steps it would be. We had no idea. A lot of people talked about this idea. There's no good data on it, no good science. The Verizon Data Breach Report came out, and it was fantastic because they actually mapped this exact problem. 2019 report, you can pull this down yourself. What they found is if you could increase the number of steps to 10, you cut the success of the attacker in half. If you got to 15, no one was successful over 15 steps. Most attacks were somewhere around 5 to 10. So if you could just look at your controls by a persona and figure out what their path was likely to take, use some things like attack MITRE framework, right? And figure out, hey, could we add in a couple of those controls? We could bump them closer and closer to 10 and cut their success rate off at the knees. So, persona, threat model, increase the steps. And then make those steps unfamiliar, which is something we're not good at, right? In the cloud, with DevOps, in our houses with IoT, we have a lot of monoculture. It's a lot of the same systems being pushed out the same way again and again and again. When a Docker vulnerability hits the streets, they can spray it everywhere and get into a million different things. On Shodan, you can scan for any number of vulnerability and find like 1,000 different examples. Right? We have a tendency in IT to set things up consistently the same way again and again and again, which is great if you're a developer writing for software that is going to execute against the system, because you're going to make certain assumptions about how it's installed, what's running, what the username is, what the password is, what the environment is, etc. We need to flip that on the head and make for very scary fields, unusual fields, different fields. Get away from monoculture, find ways to break things. One of my fun ways we used to do this was completely accidental. In the old days in Citrix, you'd run Citrix on the M drive. M for metaframe. Yay, metaframe. I don't think it's been called that in like 20 years, but hey, M for metaframe. So you'd run on the M drive, software would run, everything was great. Viruses run, they'd be looking for the C drive. C drive didn't exist, the virus would crash. We stopped NIMDA that way, right? We saw all NIMDA infect our boxes, it couldn't get to the C drive, it would just run there until we task killed it. Small little tweaks they're not expecting. In the early days of ransomware, one of the first things ransomware would do was check VS Writer to make sure it set off the snapshots. I know people who had scripts that would change the permissions around VS Writer, so when you checked it, it would give back an unreadable error code, and that would stop ransomware. Small little changes. Running on different ports, right? Why does everyone run SSH on port 22? Small little changes. Make those steps unfamiliar to slow the guys down. And then find ways to make it inhumane. And I think that is where we start talking about this tug of war between usability and security. Right? Everyone is concerned, oh, if we make it more secure, it's less usable. But if we can find ways that we increase steps to the attacker that are invisible to the defender, it's not. It's in a situation where we can add that security in without making it, without impacting usability. This is actually, I would say, the art of cybersecurity. How can we add controls that is completely invisible to users? Things like logging, of course, monitoring, security through obscurity, which you don't want to do in isolation, but changing little things, ports, protocols, and whatnot. Setting up thresholds, which we'll talk about in a minute. Behavior analytics, I think, is going to be huge for this, but we're kind of still too early to tell. But figuring out ways that we can allow users to keep doing what they're doing, but slow down the bad guys. Password cracking is one of my favorite ways to do this. And it actually shows an example of helping the user, making things easier for the users. Giving them a password manager, not a logbook. I just like the logbook. But giving them a password manager, hey, let me set up your passwords. Let me show you how to rotate your passwords. Let's use a password manager to do it. We're going to increase the complexity of the passwords. And oh, by the way, now that you're using a password manager, your life is easier as a user. But the passwords are more complex. So, of course, it takes the criminals significantly longer to go ahead and crack them. Simple things like that. The workflow I was talking about earlier with HR onboarding, I know a CISO who sat down with his HR team. His HR team was collecting by paper people's personal information, their bank information, their identification, all the sort of stuff that you need to onboard. So they're collecting all this and shuffling these papers around in file cabinets and locked drawers, and people had to fax it in. Why you're faxing in this day and age, I have no idea. And it was a lot of like really bad process. And he's like, why are you doing all this? The HR person's like, because we don't have a system for it. I'd love to build a use case or a business case, but I can't. And the security guy's like, well, what if I helped you with that business case? And together they collaborated. They put it in a secure HR system that was fully encrypted, protected all the information, fully online, simplified the process for HR, but also greatly increased security. Things like that. How can we make it easier for users? And how can we add steps that mess with the criminals? This is one we used to do back when Backtrack was a thing, but the same concept applies, right? Backtrack, as you guys all remember, had the username, root, and Tor. That was the default username, root, and Tor. Backtrack, as you guys may also remember, has a very predictable MAC sequence. So you put in one of these CDs, you boot it up, you could usually detect when it was on your network. So we wrote a script that would find that and simply execute a shutdown command. Whenever we saw people come in, right? Green pen test guy comes in on a Monday, puts his Backtrack in, boots up, it would shut down. Boot up, shut down. He doesn't want to tell me as a security officer that he can't get his Backtrack to run. Like, how's it going? He's like, oh, good. I'm doing reconnaissance. It's all good. Shut down, boots up, shut down, boots up. I'm watching him like get onto like, the forums. Hey, has anyone seen this problem? Let it run for like 2-3 days. Right? And a 5-day pen test, fantastic. So, did that affect users? No, not at all. Would it stop an APT? No, not at all. Is it really fun for most people to try? Yeah, it was. Whitelisting is my other way I love doing this. Whitelisting applications so that the code doesn't run. The malware won't run when it's on your network. Now, there's 1,000,001 ways to get around AppLocker. I've given talks about getting around AppLocker, right? I get that. Anyone who's seen this is like, whoa, an APT could rappel down, use their attack hit, and insert a random character, like a caret, and that would bypass your entire AppLocker. I get that. Is that our persona here? No. Simple malware that's going to run all the time, or someone who's doing something stupid on their network, right? Whitelisting in my box and whitelisting in my DNS is my two most strongest controls to prevent me from doing something ridiculous when I'm browsing and clicking on whatever I'm browsing, clicking on when I'm exhausted at 3 in the morning. Saved my butt 1,000,000 times. And then we can also look at ways of putting steps in place where criminals do something in a predictable way. In Detroit, in the automotive sector, there was a big outbreak of this. People would have Office 365. Criminal would phish the person with Office 365, right? Then once they're in their account, they would set up a whole bunch of forwarding rules so that when the customer received an email from the purchasing person, it wasn't the purchasing person, it was the attacker. The attacker sends the email to the purchasing person's Outlook rule, strips it all out, puts their information, forwards it on to the customer sends it back, forwarding rule, strips it all out, sends it back to the attacker, and in the purchasing person, it gets deleted, so they never even see it in their inbox or sent items. Really kind of a clever attack. Problem is that the attackers were using this in the automotive sector to say, hey, we got a new invoicing site. We know you owe us $1 million. We'll give you 20% off. Every purchasing person in the world is like, I'm going to make my bonus. I saved the company $200,000. So they'll pay that invoice, not realizing that it's now in a criminal environment, and now the criminals are routing a whole bunch of cash out of that company. Happen quite frequently. Very, very simple way, again, with this idea of steps that don't impact users, was to set up monitoring in Office 365, where if anyone creates a forwarding rule, that is alerted and sent to the security team to investigate. Not blocked. We want people to still be able to do their jobs, but an alert that's taken seriously enough that the security team then does an investigation, stops that type of attack. Very, very strong by putting a control in place where they walk. You can also do things like setting up honeypots. There's lots of arguments about should I do that? When's the right time to do that? How complex should I do that? I like just simple things. Port listeners on a SQL port or SSH port, internal, where no one should be scanning or doing stuff that wastes a pen tester's time. Awesome. Love that. One other example, this was when we were the pen testers. I was running a pen test team and we were investigating this site and they couldn't get in. They're running a crawler, which of course created a whole bunch of 404 errors, as a crawler would do. They're running a SQL map, and which of course creates a whole bunch of 500 errors, as one of those tests would do. And this was relatively recently. And then what they find is they'd run this and then be locked out for like 5 minutes. What the hell is going on? So the site was running Nginx. And so we talked to the site owner. He's like, what are you doing? He goes, oh, it's simple. I've got a rule, a threshold, that if someone creates so many 404s or so many 500s in Nginx, that I'll deny their IP address access for 5 minutes. Like, really? He goes, how often do users do that? He's like, not very often. And if they do, so what? They'll browse Facebook for a few minutes, they'll come back to my site. He goes, but it drives the red team crazy. Because can you imagine, you're just like, I found something, boom, you're blocked for like 5 minutes, right? And it was one of those things that just was like, man, that's like back in the day when I used to use Backtrack. It's the same type of concept, the same type of idea. How can we think about it as the battery life for the criminal, and how can we run that battery life down, exhausting their resources, exhausting their time, exhausting their attention, by adding small steps that are transparent and invisible to users? So when I talk about designing for defensibility, what I'm talking about is increasing the friction and increasing the effort, making it more difficult for them by using those exact same design principles in reverse. So in conclusion, painting is easy when you don't know how, but very difficult when you do. I think this is like the quintessential security rule. I love kids getting out of college and sitting down with me going, I know everything about security. We just need to apply these controls. I'm like, yes, it's very easy when you haven't done this. But when you're securing organizations that have been around for decades and have lots of legacy debt and have developers writing consistently vulnerable code and have IT guys installing consistently misconfigured systems, and now we introduce the cloud where there's even fewer controls, it is very, very easy to do security until you actually go and do it. There's several design principles in industrial design. I've touched on a lot of these in various ways, but contrast the comparison between different things so you know where you're at. Proportion, does it make sense to you? Proximity, pattern, unity. How are people moving through the system and experiencing these controls? By using these design patterns as a way of looking at a workflow, as a way of looking at wayfinding, and then giving them good choices, I believe we can give them better experiences and make it better for the users as well as better for the defenders. And then thinking about it in terms of those three ways, right? Usability, defensibility, manageability. Reversing those ideas to make it very difficult on those who are breaking in. That's the artistry of cybersecurity. And it's not easy. It's not an easy idea by any means. I'll give you a paint by numbers, and then I'll wrap this up. So here's kind of like the paint by numbers approach if you're going to follow this. One is select a process, prioritized by risk. What does it mean to the organization? What benefit is it giving when it's up? What cost do we pay when it's down? That's risk one. Risk two is what is the value to the criminal, right? There are some very valuable processes to a business that criminals don't care a lot about. And there's also some very not so high value, not so high visibility processes to a business that criminals do care a lot about because it's got resellable data or it's got compute resources they can steal. There's some way they can monetize it. So risk prioritizing those two ways. Identify the controls. Here's the steps the defenders are going to take. Again, attack framework is great for this. Here's the controls we can put in place. CIS, PCI for cardholder data, HIPAA, for whatever your control framework is. Picking out a standard control. And then applying it in a way that good reduces steps for the user. Neutral doesn't add steps for the user. Negative increases their friction. So finding ways that we can put those controls in place by sitting down with the users and making it as easy as possible on them so that they will buy in, so they'll keep doing it. And then the opposite side of it is making sure that those steps, those controls, are on the path the criminal is going to take to that data. Doing threat modeling, doing attack path analysis, adding those steps in to increase the friction for them. And the final step is establishing some metrics for feedback. This is an area that folks don't often do, right? We say, thou shalt. We have no idea if they are. When we were doing the code analysis, how am I doing on time? I got 2 minutes? All right. When we were doing the code analysis, we were doing a lot of passive analysis, and we were finding vulnerabilities consistently. We were doing pen testing, we were finding vulnerabilities consistently. And one that kept popping up, every single pen test, but in a different app, was this bypass that allowed them to get from the app into the database. And it would happen, and we would complain about it, and developers would look at it, and they go, okay, we'll fix it. And they'd fix it, and then the pen testers would come back, and they find another app. And this went on for way too long. I'm embarrassed to admit how long this went on before I got the lead developers. We got in a room, and I put the code up and go, what is that? So I was going to make him, what is that? And he goes, oh, yeah, I recognize the code. I mean, you damn well better. I show you that code every quarter. He goes, no, that's not what I mean. I go, well, what do you mean? He goes, I recognize that code. I go, what is that code? He goes, that's our standard code for accessing a database. That's in our template. Every single time they instantiated a new app, they pulled down this vulnerable code, and they built it into their app, and they would only fix it when the pen testers came and pointed it out. That was their workflow, right? It was only by having that metric and that feedback that allowed me to sit down and say, wait a minute, you're doing what now? And when we looked at their standard template and had the pen testers test that, the number of vulnerabilities we found went way down because they started from a clean slate. So we want those metrics. We also want ways to be kind, right? I call this like the Doctor Who rule. The Doctor Who rule of security is this: kindness is the ultimate security control. If we can find a way to be kind to our users, kind to the mankind that is talking to the machine, we can find a way, hopefully, to influence them and co-opt them into doing things in a consistent, secure fashion. Here's some paint by numbers for how to do that in culture. One is use those metrics to drive training, specific training, not PowerPoints that they click through once a year. Having that training part of their job process. Here's how you build an app. Here's a secure way to do it. Doing supplemental trainings and adjusting that training content based on the metrics, so that when things do get found, we adjust the training to make it more appropriate, and we make it more frequent depending on what they're doing. Getting away from this annual abstract thou shalt training to here's how you do your job. Here's how your job is going to be easier if you follow these steps. Here's why we're asking you to do it. So in conclusion, I like the idea of cybersecurity as art. I think we all came from a technical background. We tend to think about it technically. Apply this control, people follow the control, we're good. Problem is that's not working as security scales out and people do new and exciting things. So I'd argue IT does not have to be mechanical. It does not have to be utilitarian. I think IT security can be very, very creative, especially if you look at it from a design lens. And it can be something absolutely marvelous and fun to find those little ways that we can trip up the criminals while making the users' lives better. Ultimately, we have to design experiences and we have to design better if we're going to keep folks using our services and doing things in a secure way. And that's my talk, ladies and gentlemen.